Hello, welcome back to the shop. Today we have something a little unusual for the channel. We are looking at a new old stock Deck and Blacker die-cast aluminum cordless drill. Now these things came out back in 2002, as we'll see here in a moment when we open this thing up. And I kind of remember when they came out. It was kind of interesting, but I recall them being rather costly. And typical Black & Decker fashion, they had some gimmicky electronic level thing and whatever. But one interesting feature is they had a battery indicator. Now, I don't know how well it works, but they had a battery indicator on the tool, which was kind of cutting edge at the time for what it is. So, this is indeed new old stock. I don't think this thing's ever been used. It may have been out of the box by somebody that tape's cut, but it doesn't look like it's ever been used. So we can just take a look at this briefly, and we'll take some good pictures of all of the marketing wank here on this 85th anniversary thing. But I thought it'd be fun to play around with. So let's take a look here at the history of Black & Decker. There you go. Few interesting things. They have the world's first portable electric drill, which is kind of interesting. I know that in this time there was a big fight in many markets for that, and Milwaukee also started around this era as well, mainly with Henry Ford making production tools for him. But here you can see the 2002. We celebrate the 85th anniversary with this fancy, handy-dandy cordless seen here in complete handsome carrying case. Another thing to make note of is the Firestorm here. I think we're going to have some of that visited on the channel at some point. And, you know, just some of the early cordless stuff back in the 90s. It's kind of interesting, the evolution of tools and how far they've come. And that's some of what I want to look at here, this being a time capsule of 2002. I think it might be interesting to see what it's got, and maybe we'll have a way of figuring out how much jam this thing has, hot rodding it with some modern lithium batteries. So let me get this thing out of this packaging, and we'll be right back. So I guess before we tear this thing out of here, we should take a look at some of the marketing wank on the rear of this thing, and what they're boasting in this fancy model. They are boasting an infinite clutch with micro adjustments. We'll see what that's all about when we get her open. 2-speed gearbox. I don't think that's necessarily groundbreaking, but it's a nice feature, and not all drills actually had 2-speed gearboxes at the time, so it's not overly, you know. The electronic level, we talked about that briefly, and we get this thing powered up. Maybe we'll see how that works. And the battery level, that's an interesting feature. And it's rubberized, enhanced grip pieces that are standing proud here of that, and we'll see how it is. Maybe it's kind of a nice feature. I mean, if it is an all aluminum tool, this stuff maybe gets a little slippery. I don't know. I've operated other aluminum tools and I haven't really had issues, but it kind of makes it look retro-esque, I guess. I don't have any of the old Black & Decker tools, but the circular vents was a big thing at one point in time, and they went for their old branding here and everything. So I think it's pretty neat. Let's get her out now and see what it looks like. Alright, so here we go. We got this thing out. Let's take a look at what we get. I don't know, some sort of Black & Decker, I don't know, battery thing maybe. And here's the charger. Now, I guess this is kind of a little foreboding for the times to come. They didn't even give you a nice charger This is a plug-in dealie and a thing that clips onto your battery. You can see the age of time has created some oxidization on those fasteners on this thing. But yeah, I mean, that's value engineering coming in here. I mean, this is really light and kind of chintzy, but it looks like it has an indicator here for charging, and this super thin cable that won't last in a real shop more than maybe a month, being generous, unless you're really careful. So, you know, that's some of what you started to get in that era. Things started to be made cheaper, and like I like to say, value engineered, and storage cap, yeah, it comes with a little thingy. So let's get that stuff off to the side. Let's get to the main thing here. Get this handsome carrying case out. Oh, it's got desiccant. Don't eat that. So here we go. Here's the drill. Unsurprisingly, it doesn't work. The battery probably has never seen a charge ever. Oh yeah, it's got a protective plastic dealie on there. Let's see, that comes off. I mean, they went with a silver battery to try and make it look like it fits. I'll see if I can get this thing charging. I'll monitor it, make sure it doesn't get hot, and maybe we'll have something to play around with here with this battery in a little bit. Okay, so truth be told, we'll take a look at this thing, but we actually did source some new Chinesium, you know, keep your old tools running batteries, and we'll slap one of these in here and see what tight fit. Yeah, I don't know. That might not be going in there. So, unsurprisingly, if you want to try these Chinese batteries, they don't actually slide onto the tool very easy, so there's some plastic that'll probably have to be modified on that in order to get it to work. But let's take a look at this drill. So they have at the time, pretty standard chuck. I mean, it's not really a high quality chuck. It's not a crap chuck, but it's kind of on its way there. But at the time, keyless chucks, you had to hold part of it and, you know, tighten the other part. You had to two-hand the thing because the tool, we're hitting the clutch here. Let's get it around. Now the tool, you could turn the shaft in the tool, so that's not something that you're used to today. When you mess with your modern drills and stuff, the drill shaft locks, and you can't turn the rotor of the motor. So that's, you know, sign of the times. Here's that level thing that we talked about earlier. Here's that rubber, and it's actually nice. I don't think it's bad. It actually does have a decent feel in the hand. It's not overly heavy. I was wondering how heavy this thing was going to be, being all aluminum, but you can see it's put together pretty well. For a die-cast tool being made in that era, it's actually not bad work. I'll be kind of curious to see how the thing runs, which gets us to our next part of this. I got an adapter for Black & Decker 18 volt to M18 Milwaukee. Milwaukee's what we have here on the channel. We have the batteries, so it's kind of how I feel about the cordless stuff. You kind of buy into a line with the batteries. I don't want to have a ton of different batteries around, so I plan on running this thing on Milwaukee batteries. Let's see if this thing fits on. Okay, so it will fit on, but the problem we're going to have is that it appears Black & Decker, when they made their differences for 14.4 and 18 volt. I don't know if they had any other voltages in this line. The 18 volts are longer so that you can't snap that into here. So that makes sense. They always try and make these things that you can't use the wrong battery on the wrong tool. But yeah, that's never held us back before. So I think what we can do, we'll take this converter apart, and we could probably shorten that to match the dimensions, and we'll measure the actual Black & Decker battery, one of these Chinese ones. But we could probably shorten this up and get that to sit on there, about like that. And we might be able to run this thing on M18 batteries, which would be freaking sweet. So let's get to taking this thing apart. It looks like it's got Phillips screws in it. So we'll get started on this, see what she looks like inside. Okay, so we got this thing apart, and right out of the gate, something stands out that I actually kind of like about this adapter is, I don't know if you can see that or not, but that appears to be bust, which means this piece of metal is one piece with this piece of metal. Some of these adapters that I've seen in the past and taken apart, they're actually, yeah, you can see right there's a solder joint. Actually, we could probably take this apart. Let's just take it apart right now. And we could probably get that out. So here you go. You can see that's soldered together. It's not the world's best solder joint right there. But this one looks pretty decent. But that's actually really good because that'll allow a fair amount of current to pass through it. So that's actually really nice. Kind of happy to see that. And it looks like this this base may be a one-size-fits-all base that they screw onto various different adapters, as well as this. This has screw holes that aren't used as well. So they might have a modular adapter system designed here for these tools, which actually isn't all that bad of an idea, that they can, you know, have a few different things going at once. And this will go back in here. And again, anytime you start screws in plastic, run them backwards until you feel that little pop that it goes in, and your screws, almost always, you never strip them out and they stay nice and tight because you're reusing the existing thread pattern that was in the plastic. So this is a good piece. Now this might get a little bit more interesting than I was expecting. Try and shorten, but we will come up with something. And really what we need is to shorten this. You can see that it'll sit nice, just like that on the face of the drill. It'll actually look pretty good. But it does want to spring out, which you would expect. So there you can see there's a spring. There you go. Now you can see there's a spring inside the tool to reject the battery and get it out, helping the everything. So this is your release for the catch here, and that is probably going to have to come back to about here. Yeah. So we'll have to cut a little bit out of this, but let me play around with a few things, and we'll give this a go. Okay, so anytime you do modifications, you kind of want to compare a few things, and we have our original battery here, and it appears as though our difference in length is just over 3/4 of an inch. So what we got to do now is figure out a good spot to cut this thing. So I'm thinking I want to cut it straight across this brace, and we have that 3/4 of an inch to lose right here in this part of it. Now we're going to lose that screw, and I have an idea what we can do to fix that, but we're going to be 3/4 of an inch shorter, right like that, and I think that's going to get us. So basically we're taking that whole stud off, and we're taking right at this line. We're going to cut right on that line, and then we'll put this thing back together. We're probably going to end up having to run screws through her at a few spots, and we might even have to do some crazy gluing, or maybe even some plastic welding. We'll see what we come up with. But 3/4 of an inch shorter, yeah, that'll still be standing out. That'll actually look pretty decent. I think that'll work out. So let's get a cut. We'll get to the point of no return on this thing and see what we can come up with. I think that's the best place to cut it. I don't want to lose because you see how this is all held in there. All that's kind of integral in how this bussing stays together. We don't want to lose that, and then we can put something together. When we bring this back in, we can glue that there, and I don't know, we'll see. We'll see what she looks like once we cut through the cross section. It might become obvious the best way to hold it all together. So we've compared our dimensions from the original battery, and we've got our adapter cut, and we also got some scribe marks on here. So we just used a square, and a little fun fact with squares, you see this little knurled piece here at the bottom? It's a scribe. So what you can do then is you can make a mark, something like this, get yourself lined up, and you can drag this across, and that's what made that line that you see there, that scribe. So just a little fun fact, squares have those in them, and they're pretty handy to have. So anyway, we have a secondary mark here that we can cut on, and it is the difference between this and what this was. We can see our bracing, we kept that along there, and there's our profile from where we cut. So we'll still be in the same stuff, and then we may have some plastic welding we're going to have to do to clean this up a little bit to make it all hold together if we can't find holes to get bolts in. Alright, so after a little bit of screwing around, you can see what we ended up with. We have our adapter. It's still cut. I didn't attach it to itself yet. But we have our adapter, and it fits the lines of the drill nicely. It's hooked on the back on the catch, and you can see the radiuses match here, and the radiuses all match here. So I'd say we're pretty good to go with this adapter, and in fact it comes out just like that. There's our two halves, and it should be just about like the original battery once we get it all fastened together. I think we might try plastic welding it. We may make a mess out of it. I don't know. We'll see what we get. I'll probably try the sides carefully and see if it works or if it's going to be a mess. So there's that, and here's the moment everybody's been waiting for. This old battery actually has a little bit of charge in it. You can see that. She runs. I don't know if we're at full voltage yet. No, we're not. It's dead. Let's see what the battery meter says now. It says nothing. So this battery wasn't on charge long, so I can't be overly surprised, but I did want to just see if the drill ran, which it does. So now we can go on to the next step of our converter process here. And all we really did was just cut this thing, cut it rough, and then take a file and start, hold it as square as possible and start filing. And just keep taking away a little at a time until we got it to a fit that we were happy with. So nothing overly complex. Okay, so I think I have an idea here what we'll do. We lined up these holes, drill the pilot into here. Now, I think what I'm going to do, unfortunately I don't have a whole lot of options here. I'm going to have to drill a hole so I can get the fastener down, and we'll probably customize our nuts to get them in there, but the fastener has to be flush with this face so the battery can, or the adapter can slide on and off. So all that being said, we're going to send a hole through here. Try and make it as square as we can. Just like that. So we have our hole straight through. Now what I need to do is I need to measure what the OD of this screw is. Okay, so we're at 230-ish. Now, the countersink degree is different between this drill bit and a screw, but it's kind of close enough for, horseshoes and hand grenades type situation. We'll just have to be careful with it here. I don't think I'm going to hit outside. We're definitely going to drill through this layer, but I don't think I'm going to be drilling through this. So we're just going to have to take it nice and easy. Nice adapted drill there. I gotta say, these old NiCad drills, they really have a nice grip. It's very thin, nice and handy. The M14 batteries work very well with it too, so there's that also. Okay, so we're just gonna be nice and easy here and see what happens. Now I knew we were gonna break that out. That's not a surprise. Yeah. So I went through on that one. That was not what I planned on. That kind of sucks. But we'll adapt and overcome. These are very sharp drill bits. Okay, so that one I think I got right. Just have to clean it out a little bit. Just like that. Hopefully that will sit flush or close to. Close enough to that I think when we tighten that down, it'll be flush. Now for our other one that we made a nice screw size hole, I think what we'll do is get that in. Actually, we might have gotten away with it. Yeah, we might have gotten away with that. Okay. Let's keep going here. Now we need to figure out our diameter here. Okay, about the same. And we need to get the flats of our nuts the same. So what I'm going to do is I'm going to put these on a longer screw, and I'm going to try and turn the flats down so that that'll fit inside there. So all I'm doing here is I'm taking our band file and I'm just kissing the tops of these to round them off, and I'll show you what we'll do then to make sure that they don't turn when we tighten the screws. So here's an instance where that variable speed comes in real handy, just to finesse that a little bit. And you can see we still have a little bit more to go. It looks like I basically need to be the OD of the keeper. So let's have at it. Let's do a test fit now. We're getting there. We are getting there. So what I want to do is I want to have this close that I need to actually press fit it in. And my hope is that that extra push in will actually keep this from turning. So all I'm doing is I'm just turning it a little bit more each time and working back on itself. You can see we're relatively round. I mean, this is getting pushed into plastic, so it doesn't really matter that much. And I might go just a hair more, and we'll see if we can push this one in. So we're just playing around with the variable speed there, seeing how well it works. And I think that's where I want to be. So let me get that off of here. And maybe we can use this extra long bolt to set this. If we stick this like that, get it started, and then pull that down in. See what we got there. Just like that. I think I gotta use something else to try and set that, but you get the idea. Okay, and as you can see, that worked out pretty good. All I really did was take a pin punch, lined it up here, and tapped it in with a mallet, and that got us good and flush. The battery shouldn't be affected by that at all, and that should hold in. I made sure to get the nut all the way into the depth of the cavity, and that should ensure that we get that as tight as we possibly can. So I'm going to off screen turn down the other nut, get it in there, and then maybe we'll see if we can get these screws in and see if I have to deal with the uh-oh there, or if I'm going to get away with that. So we got this thing together, cleaned up our little bit of burrs and stuff that's in there, and it's holding together really nice. Everything's nice and straight. And it turned out that the mistake that we made, drilling the hole and sucking it right through, actually turned out to be exactly what we needed to have a perfect countersink for this. So, mistake worked out. So these screws turned in flush. You can see we're flush here with our nuts. We have the original fasteners here holding the bus section on, and these here. If this gets loose, we could always glue it or do something with it, but honestly I don't think it's gonna, because this goes into the tool and holds everything together that way. So I don't think that's really gonna be a problem. So let's try our Milwaukee battery. Just like that. Oh yeah. So admittedly, this is now a 14.4 tool that is running on 20 volts, or at least 18 M18, but it's 20 volts. So our battery indicator obviously is going to read full. You're going to have to use this one. If there's no battery management in this tool at this point, so you're your own battery management. If the battery gets below the charging levels of the battery, you've ruined your battery. So, public safety disclaimers aside, that's pretty nice. So let's just take a look here at this goofy level thing. Oh, look at that. It tells you, there it is, and all the way to there. So that really, and you can hear the trigger. there's a dead spot there that allows you to use this if you half cock it. So, and it kind of dims in if you see that. But it's got a pretty large range where it's full bore there, so I don't think that's overly accurate. But low speed, high speed, I think this is going to be a great tool to have here in the shop. I kind of like these old drills. I may look for another chuck for it. This chuck seems kind of chintzy. Okay, so here we go. We're going to drill this with a 1/4 inch drill and test this old thing out. See how it does. Okay, so it was a little bit of a squeaky struggle through because that drill bit has drilled a lot of glass fiber reinforced plastic. So probably not the best choice there. But we're going to up the ante a little bit. And we're going to send through a 3/4 hole saw and see how this thing does. Hopefully I can hold on to everything here. Camera wants to take a dive. Let's see what we can do. Okay, so there we go. You can see that got good and hot. Because again, drilling glass fiber reinforced plastic. But we definitely got a hole through there. And that was actually on high. I didn't have the trigger squeezed all the way. But yeah, we got ourselves a hole. And that thing is hot. Anyhow, that's a successful test in my book. So there we go. This is just a fun little play project here. I actually really enjoy using these old drills. There seems to be a whole new life that comes into them when you put modern lithium batteries on them. They have their own unique feel. You probably saw we use this old 12 volt drill here in the shop a lot with an M14 battery. It's kind of fun playing around with them. You do have to be careful with your voltages. You see, don't get below. My policy is I get down to 1 bar on here. I don't let it battery get down to the point where it flashes. I get down to 1 bar, I shut it down. But for being built in 2002 as a die-cast tool, this is very unique. I mean, they didn't really make die-cast tools for quite some time by the time you get to 2002. So that's an unusual thing in itself. It's an anniversary thing, yeah. But these things should be used. So part of the fun with this is giving the old tools another chance at life. They work good. They still get the job done. They don't have... Well, I guess we'll find out in the future here. Or we got some ideas on how to test some stuff. We're going to see how the power stacks up with these and some of the more modern tools. Reliability and everything. This does have variable speed. So there's some electronics in here, and I don't know how robust that stuff was at the time. So there could be some, if you get it hot, drilling a lot of holes with dull hole saws and stuff like that, probably the variable speed is going to be one of the first things to go out of this. But from these old batteries, these old NiCads, to the modern lithiums, it's a huge difference. It's amazing. So if you have any old tools, dig them out, give them another chance. This just goes to show that you can, we adapted an adapter. Let's get this off of here. And basically made an adapter. This was an 18-volt adapter, and evidently these adapters you can get online, the 18-volt, and we cut it down to work with the 14.4-volt. The Black & Deckers of this era, the 18 volts were longer, and you saw in the video we cut it down. So that's we adapted an adapter, and we got this old thing to run again. So that's just kind of fun stuff. Play around. Don't throw out your old tools. They still got a lot of life in them. Hope you enjoyed this. Thanks for watching, and have a great day.